In this video, we're going to look at question 13 from Worksheet 9 from Learning Outcome 2 for Engineering Math 3. And this is an example where we need to use integration by parts. The temptation when we see an x or x squared part in an integration by parts problem is to select that for our u value. But we won't be doing that here, and the reason for that is we don't have a standard integral for log x. So selecting that as our dv by dx term would mean needing to integrate it, and that's not something we can manage here. So we need to select u is equal to log x, meaning we have to select dv by dx, dv by dx is equal to 5x squared. And it is worth pointing out that the 5, we could actually select 5 log x and x squared as our two terms here. It doesn't particularly matter. So we find du by dx, which is 1 over x, and we find v, which is the integral of 5x squared dx, which of course is 5x cubed over 3. That's our standard integral for an x to the power. We increase the power by 1 and then divide by the new power. So let's put this into integration by parts then. So this is going to be equal to, and we'll throw up our square brackets just now because we're going to be eventually substituting our limits in here to find the value of this. We've got u times v, so we'll have log of x multiplied by 5x cubed over 3, subtract the integral of v, so that's our 5x cubed over 3 again, multiplied by du by dx, and that's dx, that integral. Put our square brackets, close that, and put our limits in. And you can see in this integral inside the square brackets, we're going to have an x cubed divided by an x, so we're going to be left with an x squared term, and that's something we can integrate directly, and we're going to have an expression very soon that we can put these limits into. But let's take the necessary steps to do this properly. So we'll tidy up our term on the left, 5 over 3 x cubed log x, minus, we can take the 5 over 3 out of this integral, and it's the integral of x squared to dx, because the x cubed divided by x gives us x squared. And then we can carry out that integration on the next line. So our term on the left-hand side of this is the same, and we've got 5 over 3 multiplied by the integral of x squared, which is x cubed over 3. And just as a matter of tidying up, we'll take one more line before we put in the limits. So we have 5 over 3 x cubed log x minus 5 over 9 x cubed. Now, I did say that was the last line of working there, but it might make some sense to also take a common factor in here, because this can make the final steps in our calculation a little easier. So we'll do that. So what we'll do is we'll take a common factor of 5 over 9 x cubed, which is going to give us 3 times log x minus 1. Of course, our limits are 3 and 1. And now we'll substitute in our values here. So the upper limit's 3, so we've got 5 over 9 times, it's a dot rather than an x, cross them, times 3 cubed, 3 log 3 minus 1. And the lower limit's 1, so we're going to have 5 over 9 times 1 cubed, 3 log 1 minus 1. And let's deal with this. So 5 over 9 times 3 cubed, well, 3 cubed is 27, so 5 over 9 times 3 cubed is going to be 15. And we have 3 log 3 minus 1 here. We can leave that as it is, well, for now. And from that, we're subtracting this bracket here. So we're going to have 5/9 multiplied by 3 log 1. That does have an exact value. Log 1 is 0, so that's going to be 0 minus 1. And so multiplying out in the left expression, so we've got 15 times 3 log 3, that's going to be 45 log 3 minus 15. And then in our second bracket, we've got minus 5/9 times minus 1, so we'll have plus 5/9. And it's possible we could seek to simplify this further, but there's no need to do so because we're interested in a numeric answer to this, which will round to 3 decimal places. And there's different ways we could have done our intermediate rounding anyway, but what is important is that the final answer is correct. So that's what we'll find out just now. So entering all these terms into the calculator is going to yield, rounded to 3 decimal places, 34.993. And that's the answer we're looking for in this problem. Question 13 from worksheet 9.